You throw a rock from a bridge with a velocity of 20 meters per second at an angle of 30 degrees above the horizontal. How far from the bridge will the rock hit the water 25 meters below? We have our picture drawn. Here's the person standing on the bridge. They're going to throw the rock with a speed of 20 meters per second. So that's going to be the hypotenuse of this little triangle here. 30 degrees is in the bottom left corner. In the red is our velocity in the x direction. And in our y, here we have in green the velocity at the beginning of the problem going upward. We know it's going to fall 25 meters, and we know in the x direction we're trying to figure out how far away this thing is going to land. If I pull a few numbers out of the problem, I know my displacement in the y direction is negative 25 meters, and I know the acceleration is negative 9.8 meters per second squared. In the x direction, I know we're trying to find the displacement of how far away it's going to land. First thing we're going to do is solve this right triangle. We're going to solve for the velocity in the x. We're going to solve for that initial velocity in the y. The velocity in the x is the adjacent side, which means we can solve for it by using the cosine of the angle, which is 30 degrees, times the hypotenuse, which was 20 meters per second. When we plug that into our calculator, what we should get is a velocity in the x direction of 17.32 meters per second. We're going to do the exact same thing, but we're going to do it in the y direction, so that's going to be sine instead of cosine. So velocity in the y is sine of 30 degrees times 20 meters per second. And sine of 30 degrees is a half, so we know the velocity in the y is 10 meters per second. I'm going to plug those numbers in over here in my column, which means I can then really start solving the projectile problem. Okay, now that the right triangle part of this is done, we're going to look to actually solve a projectile problem, and to do that, we're trying to solve for displacement in the x direction. If I wanted to get that right away, just go forward immediately in one step, I would say, okay, displacement equals velocity multiplied by time. We know the velocity is 17.32, but we don't know what the time is. So like with most projectile problems, we're going to solve for time in the other dimension, in this case the y dimension, and then use it to solve for what we're really looking for in the x direction. So in the y dimension, I'm going to use the equation that does not have VF in it. And the reason for that is I don't have it, and I want time instead. So the equation is d equals v naught t plus 1/2 at squared. This is a quadratic. We're going to have to use the quadratic formula to solve for time. I've already shown you how to rearrange this equation for time using the quadratic formula. It would look like this. Time equals negative v naught plus or minus the square root v naught squared plus 2ad all over a. So I'm going to take that, I'm going to plug all of my numbers in. Negative v naught is negative 10 meters per second plus or minus the square root of 10 meters per second squared plus 2 times negative 9.8 meters per second squared times d, which is negative 25 meters. Let me just extend my square root symbol, and all of that is over negative 9.8 meters per second squared. Quite a bit to plug into the calculator, but I bet we can do it. And when we do, we're going to get two possible answers because of the plus or the minus. We're going to get the time could either be 2.44 seconds, or time could be negative 1.25 seconds. Only one of those times makes any sense, and that's going to be the positive 2.44. We don't deal with negative time in this class because negative time doesn't make any sense. So while mathematically it's a possible answer, it doesn't actually make any sense here. So we're just going to say 2.44 must be the time of how long from when you throw it to when it lands in the water below. With the time of 2.44, we would now be able to solve for how far away it's going to land in the x direction. Again, displacement is velocity multiplied by time. So how far away it's going to land is going to be 17.32 meters per second multiplied by a time of 2.44 seconds. And when I plug that into my calculator, what I end up getting is 60.6 meters.